this information to their nutritionist, for example. Well, this service can be very, very useful for diabetic people, but it can't be used by somebody who has a visual impairment. What do I want to say with all of this? Well, the lack of accessibility in these terminals, these phones, automatically leads to a certain part of society being excluded. These people can't have access to the telecommunications services that are available to the rest of the people. So this is at the basis of the ETSI project. The objectives are to research, study and evaluate the accessibility of services which are going to be available in the short to medium term, to develop a roadmap for interaction or interactive technologies over the next 10 years, and to identify areas in which we may come across accessibility barriers. It's not just about identifying problems. As the Argentinians would say, the problem's not important, what's important is the solution. So we are looking to help find solutions for these problems that we're going to have in telecommunication services over the next 5 to 10 years. On the website of ETSI, you can download 2 documents produced by this project. We have, first of all, the technical report and the ETSI guide. The technical report for ETSI and other standards organizations have information really which is basic. The preliminary information which allows you to approach a standards document, which is the second one that we mention here on this slide, which is the ETSI guide, which contains the roadmap itself for these interactive technologies. Very briefly, we're going to look at the different phases of the project. First of all, phase 1, we analyzed the categories of e-services that are most common in society. We've looked at services that will be familiar to you. For example, e-government. These are public administration services based on electronic resources. E-health, all about monitoring and diagnostics in the health area. Social services based on ICTs, information and communication technologies, such as the ones we heard about earlier, teleassistance, related to personal independence. Then we have domotics, the digital home, e-banking, e-commerce, information services, for example, news, weather, sports. We've got e-learning, mobile office applications, games. And for all of these services, we've identified a pattern. And to do this, we defined certain service components. These are the components of telecommunications which frequently appear in that service category. On this slide, we can see communication services from face-to-face, communication among many people, such as conferences or messaging, fora, email, instant messaging, or services based on contents and contexts. We developed a roadmap for future interactive technologies in which we have tried to relate. At the top left, we have service clusters. These are the categories. And via these components that we've seen, messaging, person-to-person communication, contents, etc., we have developed a matrix where we have these service clusters and what we're interested in at the end. And this part are the interaction technologies, and that's what I will talk about for the rest of my presentation. As we said, when faced with the problem of a touchscreen phone, it is completely meaningless if a person cannot use their vision and the coordination between vision and movement there exist certain applications. Some of the applications are contained within the phones, such as VoiceOver. Others are commercial applications which you can download and install on the phone, such as Mobile Speak by Code Factory. And, well, we could have more novel applications, such as the contour of the touch phones, the touch screens which are raised. It looks like magic, but if it's really, well, if we imagine an iPhone, imagine we have a touch screen, information available on the touch screen on the device itself. This would mean that people with visual impairment can access this information. We're talking about a kind of system of protrusions on the touchscreen. One solution involves the physical elevation, for example, using polymers or a specific electromagnetic field to achieve that, or make a part of the touchscreen raise itself. So we could be talking about electrical systems. Here it's quite hard to see, but there are 3 types of technologies that are available. Others will appear in the future, and these will make it possible to have this tactile output. So, in this project, we've been looking at different problems regarding accessibility. So what tools have we used? Basically, we've used general standards for ICTs. I'd like to emphasize one of them. It's an ISO standard. It's called Summary of User Needs regarding information technology. I wasn't involved in that standard, but I think it's a basic tool for any institution, person, research group, or company. It's essential for anybody carrying out activities related to accessibility to interactive technologies. It's not the Bible. It doesn't give an answer to everything, but it helps us to understand the main needs of a person with accessibility requirements in order to find solutions. I'm going to read the category or the cluster because I think that no doubt you'll be familiar, many of you will be familiar with this, but here we have the most important characteristics for a system. To perceive visual information, perceive audio information, users must be able to perceive the existence and location of controls, the status of the controls and indicators. They must perceive the feedback of the system. They must be able to work the functions of the system, including maintenance and configuration. They must be able to carry out actions within the time available to avoid unintended activation of controls. They must be able to have equivalent safety, security and privacy. They must not undergo personal risks. They must be able to use the product efficiently. They must understand how the product is used. They must understand the information